Hello everyone. I welcome you for a brief video presentation on the topic exception handling. My name is Bharath M. I belong to third semester of Computer Science and Engineering and Artificial Intelligence department, and the course or the subject which I am going to take through in this video is Object Oriented Programming with Java. The course code is BCS 306A. The topic, as I said, is about exception handling. Now let us look into the video. First thing, exception handling in Java. What is the introduction? Exception handling is a mechanism in Java to deal with runtime errors, ensuring the smooth execution of programs. It helps in maintaining the normal flow of the program by handling exceptions gracefully. Exception handling is a key feature of Java's robustness and reliability. This is a brief introduction to exception handling in Java. It says that it's a mechanism in Java to deal with runtime errors, ensuring the smooth execution of programs. Then this is a key feature in Java's robustness and reliability, and it even helps in maintaining the normal flow of the program by handling exceptions gracefully. This is about exception handling in Java. Now, let us see what is an exception. The definition of exception is that an exception is an event that disrupts the normal flow of the program's instruction during execution. An exception means which is an event which disrupts the normal flow of the program's instructions during execution. This exception occurs when an error or unexpected condition is encountered. Exceptions are used to handle errors while other exceptional conditions in Java programs. This is about the answer of what is an exception. Now, let us move on to the next slide. Types of exceptions. Okay, now let us see what are the different types of exceptions. We got an introduction to exception. We saw what is an exception. Now let us see what are the different types of exceptions. The first thing here is checked exceptions. Checked exceptions are checked at compile time. They must be handled using try-catch blocks or declared in the method signature using the throws keyword. Checked exceptions help in early detection of potential errors in the program. The second type is unchecked exceptions. Unchecked exceptions are not checked at compile time. They include runtime exceptions and errors, and they can be handled using try-catch blocks. Unchecked exceptions are often caused by programming errors and can be prevented through proper coding practices. This is the two main types of exceptions, which is a checked exception and an unchecked exception. Let us go to the next slide. Exception hierarchy. What is the hierarchy of exceptions? First thing is about the throwable class. All exceptions and errors in Java are subclasses of the throwable class. Throwable has two main subclasses. Exception is one is for checked exceptions and error is for the errors which come in the program. The exception class is further subclassed into checked exceptions and unchecked exceptions. As we saw in the previous slide, the two main types of exceptions, one is a checked exception and another is an unchecked exception. This is about the throwable class in exception hierarchy. Let us look at the next point, that is about handling exceptions. How do you handle exceptions? Exceptions, as we saw it, we defined it and everything. Now let us see how do we handle if an exception has occurred. A try-catch block is used to handle exceptions in Java. The try block contains the code that may throw an exception, and the catch block handles the exception. Multiple catch blocks can be used to handle different types of exceptions in the same try block. The other many kind of catch blocks are there that is used to handle different kinds of exception. What exception is there that is used? Now we can see the snippet or um, we have the syntax over here. A try block. Inside the try we have a code that may throw an exception, and below it we have a catch block, which has we have to specify the type of exception in it and the code to handle the exception. Whatever, if there is an exception, what should the program do, that should be specified. Next, it is about multiple catch blocks with different types of catch blocks or many numbers of catch blocks in a single try block or in a single try catch block. Handling multiple exceptions, a try block can have multiple catch blocks to handle different types of exceptions. The catch blocks are evaluated in order, and the only first catch block that matches the exception type is executed. Multiple catch blocks can improve readability of the code by separating different exception handling logic. A try block can have multiple catch blocks to handle different types of exceptions. So, the same way as we see in the syntax, there is a try block. We have to write code which may throw an exception. Then we have the first exception type or the first catch block, that is exception type 1, E1, and we have to write a code which will handle that type 1. Then after that we have another catch block with exception type 2, E2, and we should write another specific code which will handle the type 2 exception. These are about the multiple catch blocks. Next, we will see about the finally block. The finally block is used to execute code that should always be run, whether or not an exception is thrown. It is often used for cleanup tasks such as closing resources. The finally block is guaranteed to execute even if an exception is thrown and not caught. If there is an exception, if there is no exception, whatsoever it is, a finally block will always be executed in the end. Here we have the try block in the syntax. The code that may throw an exception will be written inside the try block. Then we have the catch block with an exception. Whatever exception we want, we have to specify it over there. And we have to write a code the way such an exception should be handled. Then we have the finally block. This finally block, whatever the code is there in the finally block, it will always be executed after the try catch block, whatever the result of the try catch block may be. The throws keyword is the next concept. Declaring exceptions. The throws keyword is used uh, in method signatures to declare that a method may throw certain types of exceptions. It throws exception back to the method or the calling method to handle it. It allows the caller of the method to handle and accept exceptions or propagate them up the call stack. We can see the syntax over here. Public void method throws some exception. Some exception is we should specify which kind of exception are we expecting from this code. And inside that block we have to write a method code that may throw some exception, like whatever exception we have um, specified up, that exception it may be there or may not be there, we have to mention that method or we have to put that method code. Next, custom exceptions. Creating custom exceptions is like it can be created by extending the exception class for checked exceptions or the runtime exception class for unchecked exceptions. Custom exceptions can provide more specific information about the error and how to handle it. Custom exceptions should be used judiciously to avoid confusion and maintain code readability. This is how the custom exception should be used. Public class custom exception extends exception. Constructor and additional methods are there, has to be written inside the block or inside the class. This is about the custom exceptions. Now let us just understand how this has to be used, because to avoid confusion and maintain code readability, custom exceptions should be used very carefully. It cannot be used as and ever. Now let us go on to the next slide. Exception propagation. Propagating exceptions. How it has to be done. When an exception is thrown in a method, it can be propagated up the call stack to the calling method. If the exception is not caught and handled, it will eventually reach the top of the call stack and cause the program to terminate. So exception propagation allows errors to be handled at an appropriate level in the program. This thing is about exception propagation, and this is how propagating exceptions are done. This is about the slide. When an exception is thrown in a method, it can be propagated up the call stack to the calling method. If the exception is not caught and handled, it will eventually reach the top of the call stack and cause the program to terminate. Exception propagation allows errors to be handled at an appropriate level in the program. This is exception propagation. Let us now move on to the next slide. Now, let us see using try with resources. This is about automatic resource management. The try with resources statement is used to automatically close resources such as files, streams, or sockets when they are no longer needed. It ensures that resources are properly closed even if an exception is thrown. The try with resources statement simplifies resource management and helps avoid resource leak. We have the syntax over here. Try resource type resource equals new resource type function, and inside that block we have to write a code that uses the resource. A catch block will be given with a try always. uh, we have to specify which kind of exception we are expecting from this try block, and we have to write a code to handle if the exception really arises. This is about using try code with resources. Let us now move to the next slide. What are the best practices of exception handling? Using specific exception types to provide meaningful error messages, handle exceptions at an appropriate level in the program, use try-catch blocks sparingly and only where necessary, log exceptions and errors to aid in troubleshooting and debugging, use custom exceptions judiciously to avoid overcomplicating the code. Use specific exception types to provide meaningful error messages, handle exceptions at an appropriate level in the program, use try-catch blocks sparingly and only where necessary, log exceptions and errors to aid in troubleshooting and debugging, use custom exceptions judiciously to avoid overcomplicating the code. These are some of the practices used for exception handling. This is about this slide. Let us now move on to the next slide. What are the common exceptions which is seen in Java? The different kinds of exceptions seen in Java. Let us see it one after the other. The first one is the null pointer exception. This null pointer exception occurs when you try to access or modify an object reference that is null. Next, one of the most common exceptions in Java is null pointer exception. This is often caused by improper null checking. Second one is array index out of bounds exception. It occurs when you try to access an element with an invalid index. This can be prevented by validating array indices before accessing them. This is about array index out of bounds exception. Illegal argument exception occurs when a method is called with an illegal or inappropriate argument. This common exception, which is illegal argument, can be thrown by methods that validate their arguments before processing them. These are the first three types of exceptions in Java. We will look at three more kinds of exceptions. The first is illegal state exception. This occurs when a method is called at an inappropriate time or in an inappropriate way, often used to indicate that the current state of an object is not valid for the operation being performed. This is called as illegal state exception. Input-output exception is another kind. An input-output exception occurs when an I/O operation fails or is interrupted. I/O exceptions are checked exceptions and must be handled or declared in the method signature. Next is the class not found exception. Occurs when a class is not found at runtime, and this can be thrown when trying to load a class dynamically using reflection. At this time, this class not found exception can be used. Now, let us go on to the next slide and look about the common errors in Java. What are the different kind of errors which occurs in Java? The first one is stack overflow error. This occurs when the call stack exceeds its limit, usually due to infinite recursion, and this can be prevented by ensuring that recursive methods have proper termination conditions. Out of memory error occurs when the JVM runs out of memory, and this can be caused by inefficient memory storage or processing large amounts of data. This is the second error, which is out of memory error. Third one is no class diff found error. This occurs when a class that was available during compilation is not found at runtime. Can be used by missing or incorrect class path settings. These are some of the main common errors in Java. Let us now move on to the next slide. What are the best practices for error handling? Error handling, some of the best practices are seen. Using try-catch blocks judiciously only for handling exceptional conditions. Log exceptions and errors to aid in troubleshooting and debugging. Provide meaningful error messages to users to help them understand the issue. Use custom exceptions sparingly and only when necessary. Handle exceptions at the appropriate level in the program to maintain code readability. Use try-catch blocks judiciously only for handling exceptional conditions. You log exceptions and errors to aid in troubleshooting and debugging. Provide meaningful error messages to users to help them understand the issue. Hell, use custom exceptions sparingly and only when necessary. Handle exceptions at the appropriate level in the program to maintain code readability. These are some of the practices used for exception handling or error handling in Java. Debugging techniques, debugging exception handling. Use debugging tools provided by the Integrated Development Environment or IDEs to step through code and analyze the state of variables. Use logging frameworks to log debug information and exceptions for analysis. Debugging tools can help identify the root cause of exceptions and errors in the code. This is about the debugging exception handling, which are the tools provided by IDEs, which are integrated development environments, to step through codes and analyze the state of variables. Use logging frameworks to log debug information and exceptions for analysis. Debugging tools can help identify the root cause of exceptions and errors in the code. This is about the different types of debugging techniques. In multi-thread environments, handling Exceptions in multi-threaded environments. Each thread has its own call stack and exception handling mechanism. Exceptions in one thread do not affect the execution of other threads unless explicitly handled. Proper synchronization and error handling are crucial in multi-threaded environments to avoid race conditions and data corruption. Each thread has its own call stack and exception handling mechanism. Exceptions in one thread do not affect the execution of other threads unless explicitly handled. Proper synchronization and error handling are crucial in multi-threaded environments to avoid race conditions and data corruption. Exception handling practices. This is similar to what we saw a few minutes back, and this is the conclusion of what we studied till now. Thank you very much for being a part of the video. We see you soon in the next video. Thank you.